So now that we've walked through the overall program and seen how completable futures are applied at a kind of an aggregate level, at the top level stream, intermediate operation, and terminal operation level, let's zoom down and talk about applying factory methods. And you'll, of course, recall that the factory methods that we're going to deal with, as usual, are supply async. So they're going to get used here in this call. So you can see that we're going to initiate an asynchronous check to see if images are cached locally. And that's done with this map call passing in the check URL cached async method reference. And that will then asynchronously check to see if the URL is already downloaded. Now, what happens here, this is going to kind of explore this in a little bit more detail than we talked about earlier. This called a map returns a stream of completable futures to optional URLs, which will have a value if the URL is not cached, but will be empty if the URL is already cached. And I talked in the previous lesson kind of about why we did that, and now we're going to talk about how we do this. And the reason for doing this is to ignore empty optional URL values. So if something's come by, we're just going to ignore them in later phases in this pipeline. So here's what the code looks like. So check URL cached async is a method. You can see the method takes a URL, and it calls the completable future supply async factory method. And what that does, as always, is it registers an action that will be run asynchronously in the context of whatever executor we give it when we call supply async. And I'll talk more about that in just a second. But the key thing I want to talk about here is we're passing in an action. And this is what the action is. It's a Lambda expression that says optional of nullable URL cached URL null URL. So what the heck is that trying to do? Well, we'll talk about that in a second. But first, let me talk about the second parameter to supply async. For the most part, we've simply been calling supply async with one parameter, the supplier lambda, and not having it use any other executor than the common fork join pool. For various reasons, in this program, we have a helper method called getExecutor, which is an accessor method that returns whatever executor we want to use. And that can be set in some other part of the program. Now, in this particular example, we're just setting the executor to be the common fork join pool common pool. But we can change this to some other pool, and a different implementation does change it to a different pool if we want to experiment with the benefits of using other types of thread pools besides the common fork join pool. Most likely, the common fork join pool is what you need, but if you want to change it, you can. So let's go back here and look at this registered action. This registered action uses the ofNullable factory method that returns an optional URL. And the way that ofNullable works is it takes a look at the parameter that's passed to it, and if that parameter is non-null, ofNullable creates a non-empty optional, which means it's actually got a value. However, if it's passed a null, then ofNullable will create an empty optional. So it's really up to the URL cached method to decide what is going to be created here. So let's take a look at what URL cache does. So what URL cache does is it takes the URL of interest here, and it uses the filters. Remember, we got grayscale, sepia, tint, the null filter, whatever you want to have. You can have a bunch of filters that are transformers. So we create a stream of those things, and we check to see whether any of those filters are already existing in the file system, given the name that we use to construct the downloaded image and filter it. So we're using the AnyMatch, the cool AnyMatch short-circuiting terminal operation to say the URLs have been cached if there's anything in the file system that already has the same name as applying the transform to an image. And here's the URL cached method that takes a URL and a filter name. And the way it works is it tries to create a new file in the file system with the name that would be created had we done the filtering. And we will return true if the file already exists and false otherwise. So if we were able to make the file, then we know the file didn't exist. If we tried to make the file and the file existed, then we know it was already there. So that's the logic that we use to see whether or not we've already got the image cached. Now, I guarantee you there are better ways of implementing an image cache. This was just a clever way I did it so I could use it for the example. A much better way to do the cache would be to use the max age header tag in an HTML request to keep track of how long something was considered alive or viable or non-stale, and use that as the means to be able to determine whether or not something was in the cache or not. But that's left as an exercise for some future programming assignment, and I just did it this simple way. So that's the end of the discussion of how we apply a factor method. There's other factor methods that could be used elsewhere, which we'll look at later. But this is the one that starts the ball rolling by checking to see whether URLs are already cached or not.